Third time's a charm. Third time's a charm.
All right. Episode 16, version 3. This is literally the third time we've tried to record this episode. So very quickly, AI is good. Data bias is bad. AI doesn't fix everything. And please subscribe. All right. If we only get that bit, that's good. But hopefully we'll get a little bit more. How you doing, mate?
No matter what, we are releasing this episode this time.
Yeah, it may be long periods of silence or a very weird cut, but it's going out.
It's happening. It's happening. I'm doing good. This time I'm sick for it though, so ignore my natured voice.
I think what everybody is going to want to know, Tom, is it the spicy cough?
TBD. About to do a test.
Fair enough. What are you drinking? What have you got there in your?
Well, I'm not drinking anything at the moment. I'm just burning my tongue on green matcha tea.
Matcha tea.
Very nice. Yeah, I've been replacing my morning coffees with tea recently. So
just for funsies, like the taste, or cutting down on the caffeine?
I just definitely drink too much caffeine. Like, I don't believe caffeine's bad for you, but if there's a certain quantity that makes it bad for you, I'm probably hitting that. So I'm taking out my morning tea, and yes, I know green tea has caffeine in it, blah, 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 but hey, at this point.
Yeah, it also has L-theanine in it, which apparently offsets a lot of the jitteriness of caffeine. So it's a more... Yeah, you can thank Huberman for that one. I have got an Imperial Grapefruit Sour Beer. It is definitely my favorite of the sour beers. Nice little citrusy taste. I couldn't find it at the bottle shop for about 3 or 4 months, and I thought they'd stop making it, but it's back. And they also have a pink grapefruit flavor. I bought both. I genuinely cannot tell the difference between grapefruit and pink grapefruit as a flavor, but they're both good. So that's what I have this evening. Mate, what part of the world are you gracing us from today?
I'm back in London, but I'm coming home. 6th of October. I'm back home.
Very good.
That's because we'll end up probably recording this next week for the 4th time. It will probably coincide with episode 20.
Yeah, I can't remember what normal episode we're up to. I think 18. So we'll put this one out and then 19, and then we can do episode 20 in person. Fancy.
Livecast. Yeah. And we were talking about maybe switching up the format as well a little bit. Maybe a few more topics on the bit more news focused.
Yeah.
We'll see.
We will experiment.
Yeah.
Very good. Well, episode 16 is still in the classic format. I know these topics pretty damn well now, given that we've done this 3 times. But tell me, what are you going to be talking to us about today, Tom?
So today we're going to be running through a paper that is talking about how machine learning is unable to help us has been unable to demonstrate an improvement in predicting consumer choices in marketing. A paper by someone out of the University of Chicago and the University of Stanford. But yeah, we're going to jump into it, not discuss why AI failed, but I really wanted to talk about how really this is just machine learning being applied in a poor circumstance or situation, rather than a AI failing. And then, just so we're not slinging stones the entire time, I thought we could talk about thinking about how we could use ML to improve prediction around consumer choices. So that's my topic today.
Very good. Very good. Ooh. There's an angry pup in the background.
He doesn't want me to talk about it.
The dog is going to talk about his opinions on AI. No, I read a paper probably about a month ago now. I've read it several times in preparation for this podcast, but in a similar vein, it was a group from an agricultural research group out of California who built a robotic setup and a big AI setup to estimate yield in their vineyards. And I think, again, it falls into that category of, maybe this wasn't the best business decision. Even if it was technically possible, the ROI doesn't really stack up. So we'll talk about that under the same vein. And hopefully we'll catch all that content, and that'll see us through to an hour. But mate, why don't you kick us off with marketing?
I'll jump in. And I'll try and remember all the funny jokes that I said in episode 2 that were definitely funny and repeat them. But if they're not funny in this episode, it's because I'm just not as committed, I didn't come up with all on the fly.
Definitely.
Okay, so this paper was released in November 2020, and I think the first time we recorded this, that was only a few months ago, and now it's verging on a year ago. And the main claim was basically that machine learning has not helped us predict consumer behaviours with regards to purchasing decisions. So, and I quote, "Our main conclusion is that for most of the more interesting consumer decisions, those that are new and non-habitual, prediction remains hard."
Prediction is hard. You heard it here first, folks. Prediction is hard.
Yeah.
So let's turn that from academic speak into human speak. What does that mean? What are the authors trying to say here?
Yeah. So what they're trying to say is that, like, as a consumer, there's kind of like there's a couple of different types of choices we'll make. There is like non-habitual ones, which are probably spur of the moment, impulse shopping style ones. And then there are also new choices that we make as well. So those are, I really, really, really want to get into hiking. So I'm going to go buy some hiking boots when you've never gone hiking in your life before. So those are the interesting choices they're talking about, the non-habitual and or the new choices.
Okay. And the summary is predicting those in advance based on some consumer data is tough.
Yeah, and so what they've shown is that predicting these, machine learning has not improved our ability to predict these compared to previous more heuristic methods that were used. So that's what the claim of the paper is. So the way they did it is they looked at all of the research out there on machine learning in predicting consumer choices, and they kind of looked in 3 major areas. The first was predicting choices in response to a targeted message. So that in human speak is, could they predict whether people would respond positively, i.e. purchase from an ad? The second thing they looked at was predicting preferences and choices within recommendation systems. This was just looking at basically how good the things like Netflix and Spotify and Amazon recommendations to you were, and whether they were successful in suggesting content you wanted to consume or suggesting things that you would want to purchase. And then the next one that they looked at was being able to predict behaviors from a human psyche or an online psyche. What this means is if they could build an online psyche from all of your behaviors, from all the things you like on Facebook, from the brands you follow, from the people you follow, could they put you in a kind of person and then predict your behaviors, i.e. who you're going to vote for, what school you'd send your children to, things like that. Hot take on all 3 of these, machine learning did not prove to uplift compared to the current methods or the current heuristic methods.
Okay.
Across those 3 areas.
So I mean that's not to say it couldn't do anything. It's just compared to some more basic approaches, it's not doing a whole lot more. And as we know, training and building ML systems is complicated, both in training and production. So is this worth it? Should we dive into some of these examples in more detail?
Yeah, and I think quickly I'll just dive into like why I think these authors had the motivation to do it. And the introduction to the paper starts off with a lot of quotes from various people across the world who are in this space, and all these quotes are super futuristic and scary, kind of like if you've seen the Minority Report, painting a picture of a world where if you're feeling sad, they'll be able to present a different ad to you, compared to if you're feeling happy or things like that. And I'll just quote one of the quotes that they use to demonstrate this point, that the world believes that machine learning is going to be able to predict every single move and every single mood of you as a consumer. Technology companies have a data voodoo doll, which is a complete digital representation of our lives. With it, they can manipulate our behavior fully. And I think the authors just really, really wanted to combat this to like A, get rid of a bit of fear mongering, and B, to show that there is that this is a difficult space to predict behavior
And now that was a quote not from the authors, but one that they had seen from maybe an ML company in the wild, or somebody saying, trying to sell this as more advanced than it was.
Correct. Yeah. Correct. And yeah, I suppose that's another thing as well, is to like downplay the people that have a very, very vested interest in convincing people that their product is the able to predict things to this level of accuracy.
Yeah, yeah. There is no shortage of AI marketing tools and platforms and startups and yeah, all that sort of stuff out there. I am sure, and
Yeah.
no shortage of hit pieces from the media saying, Facebook is making posts show up to make certain people sad or whatever else. And I suppose there's probably some truth to it, but I don't know if it's quite as advanced as people think it might be. But
Exactly.
anyway.
And I think we can boil down to, and if we can answer this first question by boiling this down to kind of this statement. And the first question I wanted to explore, just as a reminder, was why this is a bad application of machine learning rather than a failure of machine learning. And a core assumption in a lot of this consumer stuff is that people have stable preferences that dictates how they make decisions. So, you buy an iPhone once, you've got an iPhone for life. You feel sick, so you buy cold medicine and tissues, like very what they call stable predictors. But in reality, there are very, very few stable predictors out there for us as consumers. And in fact, when we are making a purchasing decision, it is often haphazard, and it's often very close to the time of purchase, and it's full of things that we are basically next to impossible to measure. And it says, here's a quote from this: "Future choices will not be determined by stable preferences that can be predicted ex ante, but will be constructed on multiple factors at the time of decisions." And if you just think about that for the last time you bought something, that makes a little sense. That starts to make sense for you. And the authors give a good example of purchasing a toaster. So imagine you were purchasing a toaster. You go online and you're scrolling your online e-commerce shopping brand of choice. You're going through and you see that one does 4 bagels. You'd never thought about making bagels before, but you had a good bagel on the weekend. And you go, you know what? Being able to do 4 bagels at once, that's something that's valued. You know what? That sounds pretty good. Bang, done, purchase. Or you might be scrolling through and you're like, oh, I could get this toaster that looks a little bit more expensive, a little bit nicer maybe, but I actually spent quite a bit of money on the kettle and the mixer. You know what? I don't need the toaster to match that brand. I can get a cheaper one. And in both these situations, the idea is that there is things that pop up right in the moment that are not going to be part of a stable prediction ability. Aren't going to be something that can be predicted. It can't be predicted. So it's this like idea that there's so many factors happening for every single individual that it's almost next to impossible to categorize them into something that would be a stable predictor.
Yeah, I mean that makes a lot of sense. Yeah, for something like a toaster, I'm not a toaster man. I don't care that much about my toaster. I reckon if I was in the shops and there was a toaster that I kind of wanted and somebody else was looking at it with their whole family and it was just like there was just another toaster, I would just pick that other one because I'm not going to wait to have a closer inspection of a toaster. And I think the reality is no ML model in the world is going to be able to predict, is there going to be a family looking at the particular toaster you're interested in on the day, which makes you buy the other toaster to the left of it.
Yeah. And then I think and this is the claim in the article as well, is that doesn't perform an uplift on the current methods. So in this situation of purchasing the toaster, it's next to impossible to predict what factor is going to swing you to what toaster. However, there are certain things that are very, very, very stable predictors that don't require machine learning to be any more accurate. So, for example, if you own an iPhone, you're probably going to be looking pretty closely at the AirPods. If you are pregnant, you're probably going to be looking at purchasing a pram. These are the things, and while there might be a little bit more like deeper analysis you could do on that of demographics or spending, the point here is that machine learning isn't really going to assist above and beyond the current methods with that.
Yeah, for sure. And I think, for people making business decisions, they need to think about ROI probably a lot more than they do. In that, ML in a lot of industries is like the new hotness, and people are going to charge for that fact. So you're going to be paying extra for the AI marketing tool compared to the basic marketing tool that looks at what device you're browsing on. Are you going to get an equivalent uplift in marketing ROI? Probably not. So beware the person that comes to sell you a product mainly based on the fact that there's AI in it. Look for results, not for features.
Yeah. So in this area of predicting choices in response to targeted messages, which is predicting whether people will respond positively to ads, they weren't able to show that there was any uplift, but they were able to show that there has been major advances, and it's been in the data collection. So now we are much more likely to know whether someone is an iPhone owner, or whether someone is pregnant, or someone is considering purchasing a house. Things that are stable predictors. We're better at understanding these, and over time, these stable predictors have grown because we now have access to them. The other thing that they were able to show, though, is that where ML has really helped in this space is by determining whether small groups will likely respond better to an ad. And the way to think about that is like-to-like audiences. So machine learning has helped the marketing industry of finding people that are similar to people that have purchased things in the past.
Okay, so that's maybe people that really like hiking, for example. You might be able to pick out other people based on some, GPS data of where they are on the weekend or something, or what they post on Instagram, and you can throw them into the hiking bucket and show them hiking stuff. Is that what you mean?
Yeah, it seems to be that, and it gets into a muddy water of whether we've gotten better like gathering more data, i.e. we know that someone went hiking on the weekend, that's gathering more data, or whether it's machine learning has been able to better categorize people to determine their propensity to like hiking. But we are getting better at putting people into similar audiences as one another. Which starts to make sense. But generally, the conclusion in this space is that if there is any predictive value in a variable of whether someone will respond positively to an ad or not, it's generally a very stable, easy to identify tendency. For example, owning an iPhone, something that that is unlikely to change quickly. So that's kind of like one of the areas. The other areas will kind of like blow through the first question that they answered, which is will consumers respond well to ads? The other two will kind of run through really quickly, and we'll get to the fun stuff of us coming up with ideas of how to improve ML in this space. But the second one was predicting preferences and choices within recommendation systems. I didn't really know what they did in this section other than just rag on Netflix's recommendation algorithm, but that seemed to be what they did. They kind of looked at two types of recommendations, which is user-to-user or item-to-item. So a user-to-user recommendation system would be one that, like we were just talking about, you're similar to this user. Maybe you would like to purchase or consume what this user has purchased or consumed in the past. Or then there is item-to-item, which is these people people who bought an iPhone also likely bought AirPods. Maybe we should also offer AirPods to everyone who bought an iPhone. And I think
Fair enough.
I think we got to bring up the chook. Make sure we
Yeah,
bring up the
yeah,
chook.
yeah, absolutely. This is the
chook
hot
Terry.
chook. Yeah, so this story comes. This is a real world example of using ML in this space. So my brother was designing an ML system with a previous employer many years ago for a large supermarket chain here in Australia, and they were looking at I guess what you would have called an item to item type flow, but it was kind of like a basket to item type flow. And what it would do is, as you were scanning at the self checkout, which it doesn't seem very feasible, but anyway, it would suggest other stuff that you might want to buy
And you have to walk
based
back and
on
get
what
it.
you had already. Yeah,
Oh
which
no,
seems real dumb.
wasn't it online shopping? It was online shopping.
It could have been online shopping. That makes more sense. But anyway, the goal was look at what's in the basket and suggest an item with the goal of maximizing profit for the supermarket. And the hope was that, depending on what you picked, you'd get lots of different things and it'd be very personalized and people would feel like they had gotten good suggestions and the supermarket would make more money. But overwhelmingly in these sort of real world tests and back testing the data, it turned out that regardless of what was in your shopping cart, suggesting a roast chicken, so supermarket roast chicken to everyone, was the profit maximizing choice. So whether you're buying shampoo, your daily groceries, and they tested this literally, just another hot chicken, the best suggestion, regardless of any other factor, was to always just say, do you want to add a hot chicken to your order? And Lord knows how much money this supermarket spent on building this system to then just offer everyone a hot chicken in their basket. But
it's still so funny
yeah.
to me that the conclusion was if someone bought a roast chook, offer them another roast chook. It wasn't like offer them some mayonnaise or something, bread.
Yes. Yeah, it's a bit of a ridiculous one, but Tom and I have been talking, and we did on the previous recording about thinking about what's the hot chook in a lot of these scenarios, which is what's the default basic choice that you could offer to pretty much everybody and get 80 to 90% of your AI-driven marketing gains with just a say hot chook every time type answer.
Yeah. So remember the hot chook.
The
So
hot chook.
in this recommendation system, there was a couple of hot chooks in there as well. So Netflix just kind of ended up basically each year they used to run a recommendation system prize. It took 5 years for anyone to actually win it, and when they won it, it turns out that they won it because they were like really likely to predict whether someone would give it high stars or low star rating, rather than whether it was actually something that they should watch based on what they've watched recently. So they were just going to recommend a good show for that person, not a personalised one, depending on the mood they're in and things like that. They also did like a review, and they found in one recent interview, the authors found that out of 7 neural recommendation algorithms presented at top-level conferences, 6 were outperformed on the relevant recommendation task by comparably simple heuristic methods, i.e. just offering the hot chook equivalent. So a good example there would just be like probably just offer Drive to Survive to everyone on Netflix, and they'll probably watch it.
Yeah, or Stranger Things.
Yeah.
And I think the interesting thing here is the like competing interests of a lot of these groups in that like with this supermarket chain, the goal is profit maximization. With Netflix, it's probably get enough views on these shows to justify the, however many millions we spent making the last season of Stranger Things, which is in some cases a bit of a competing heuristic against pick a show that this person is likely to watch all the way through.
Yep.
So as a consumer, that's probably another thing to think about in a lot of these systems, whether it's Amazon's choice product at the top of your search results or whatever else, they're not necessarily optimizing for your best interests.
The other day, the place I'm staying at the moment, my hosts were watching Les Intouchables, the French movie about the man who's quadriplegic, and he hires an ex-convict to look after him, and the ex-convict doesn't want to be there. Anyway, it's a really touching, beautiful movie where they become really great friends, and they help each other find new meaning in life and stuff like that. It's a beautiful movie. And at the end of the movie, the recommendation for like what you might consider watching next was terrorism close calls SWAT unit, and then like police, like one of those police like dash cam style videos. And I was just like, Netflix, come on.
Yeah, insensitive.
But this is one little criticism of, and not criticism, limit of the paper, is that probably the best stuff out there is not released from a research point of view. Like I'm sure Amazon's recommendation system out there is not on the internet published with all of its results showing how effective it is at upselling you.
Well, yeah, I mean, look at TikTok, man. Like that is certifiably good at keeping you hooked.
Yeah.
And it's not like they're out there doing academic studies about like how to keep your users addicted to short form video.
Yeah. Yeah. So yeah, recommendation systems, as I said, not sure what they really came to here, other than that it turns out, and I think this is the thing throughout all of this as well, is that it's pretty hard to create something in the machine learning space that will outperform a basic heuristic, i.e. offer them a hot chalk. So the third area, before we quickly jump into us just slinging stones, and is they looked into predicting behaviors from the psyche, and it seems like they just really, really wanted to downplay The Social Dilemma and The Great Hack, which were two documentaries that came out and were very like scary. The Facebooks of the world know all of it, everything about us, and they're going to be able to dance us like puppets on a string, kind of thing. So what they looked at here was they wanted to look whether they could create, if anyone's been able to create an online psyche and be able to predict behaviors from it. So first off, they looked into a little bit of the research, and it has been determined many, many times over is that personality traits are really good predictors of things like voting habits or like how you're going to react to news and things like that. Apparently, personality traits explain about 5% of voting habits, and generally things like which party are you part of are much better predictors of how you're going to vote.
Who would have thought?
Yeah. Also, interestingly, they did a little like side note calculation for the like Cambridge Analytica Facebook kind of scandal, and they're like, even with the best conversion rates ever and the amount of like and the budget that they were said to have spent, they probably only got Trump's 600 votes. They said so. They did a little like sidebar calculation, which was well less than what he would have needed to actually swing the election. Also in this space, they then looked at like outside of consumer behavior, whether like in more like social outcomes and things like that, whether AI and ML could help predict. And once again, they were able to show that basically it performed maybe just a little bit better than current methods. One example was predicting whether people would return for their court date after being released from jail, and it performed on par with the other heuristic, which was, has someone been in jail and skipped this date in the past?
Yes, which brings us to our other real world story, which was again from my brother with his previous employer years ago, which was looking at tax fraud in Australia, trying to predict whether people were likely, or tax evasion, I think was the actual thing. I think just not. I don't know what the difference is in this context. But anyway, like dodging up with the ATO, which is the Australian Tax Office, and they again tried to build an ML model that looked at all this data on people to try and predict ultimately like who they should do audits on. And it turns out that there was only one strong predictor, which was, did you commit tax fraud last year? And if you did, then you were likely to do it again. But if you didn't, it was as good as random chance, and sometimes worse, using this AI model to try and guess whether you were going to do it. So, yeah. And there's many documented horror stories of this now, like that, some state in the US was using an AI system to predict whether criminals were likely to reoffend, and using that to judge whether they should be granted parole. and it was trained in a state with a much smaller African American population. So there's huge data bias, and it ended up really, really overskewing to high reoffend rates within African American populations, which was just not backed up in the data at all. So yeah, a lot of this stuff is, there are probably, in that case, there was probably a much simpler heuristic that could be used around, was the crime violent or some other thing like that, or I don't know, who knows what it is. But these AI systems need to be well tested. They're not magic. And I mean, I think, if we sidebar for a second here, other than it makes the VCs happy and give you lots of funding, what do you think it is that is making people believe that there is so much magic in these systems?
Well, I think it's just like, from a lack of a better word, branding point of view, is like you use the word heuristic, right? And people go simplified. Okay, it's simplified. I know it's not going to be right, but it's a good filter. You use the word machine learning, and people just instantly think that there is sophistication and a level of investigation well above beyond a heuristic. And so I think that people get caught up in this idea that so I think there's like a branding thing from the outsiders. One is that we like hear the word machine learning and we're like, okay, it's got to be more accurate. Therefore, we should do it because it's just machine learning. So the people that are contracting consulting companies to go and build the models of who's going to evade tax or whether we should recommend them a chook or not, they're going to be like caught up in the sexiness of ML. And then I think the second thing there is that and this is kind of why I answer of why this is a poor use of ML. And I think the second thing there is that I think people believe that if we just throw more data at it, we are going to solve the problem. If we throw more and more data at it, we're going to solve the problem. But rarely is that the case. There is rarely there is only one or two major variables or predictive variables within each of these choices. And so what it rather than like thinking that if we just keep gathering more data, we're going to like be able to construct a little bit more explainability into why someone made that decision, which is incorrect, rather than trying to build the layer explainability on top with small variables, we end up just introducing noise and make these things worse. When in reality, sure, we should be like, sure, if we have the data, but we should be actually looking for the stable predictors within them, maybe. But that's kind of my thought.
Yeah. No, I think you're absolutely right. And, in the world of signals processing and electrical engineering, there's this concept called the noise floor, which is, if you're building an antenna, the background radiation of the universe or the heat of the room that it's in or whatever factors are going to create a certain amount of noise in your recorded signal. And no matter how many samples you take, you're never going to be able to detect signals that are smaller in magnitude than the noise floor because it just gets lost in the noise no matter what you do. And I think that's pretty similar to what we're seeing here, is that you could collect, my heart rate at every second of the day, how many steps I take, my precise location, and a bunch of other factors. But if the decision is either random or buried across a million different factors that are below the noise floor, you're never going to be able to predict, more than just your heuristic estimate. And that's just a fact of life. It's not, I don't have enough data. It's just that given all the data in the world, this is not a predictable thing beyond this level of, accuracy. And a lot of that is because, we're not machines. We're weird stochastic creatures that, like, did you walk through the ground floor or level 1 when you came in, and did you happen to pass this department? Oh, that's going to change what thing you buy. Like, there's just so much randomness in these systems that we're never going to be able to overcome.
The noise floor, you heard it here first.
The noise floor, probably from some old French bloke in the 1600s. But you heard it on a podcast here first, because I don't know, Shannon probably didn't have a podcast, or maybe he did. Who knows?
Yeah. What did you listen to Maxwell's podcast? Yeah. So we're so let's switch. So I think that's probably a good reason of like why is this a poor use of ML, and the simple thing there is that there's like so much noise in the data. We like it's very hard to separate that signal from the noise, or it might be actually physically impossible to separate that signal from the noise because it's below the noise floor. And then the second reason is heuristics perform so well because there's generally only one or two stable predictors for things that we can actually predict, and therefore machine learning doesn't really provide an uplift when there's only two variables to consider.
Yeah. And I think for like a lot of problems, it's in that weird gray area in between of ROI, which is, okay, maybe if you drew my blood every 15 minutes and, strapped 15 cameras to my head to work out exactly what my surroundings were, you could predict which toaster I was going to buy. But is that really going to justify the costs of your additional toaster sales? Absolutely fucking not. So it is an effective sort of economically driven noise floor, as opposed to what we're used to dealing with in the electrical engineering world, which is like, this is the laws of physics tell you you can't get below this noise floor.
I'd love to see the name of that paper where monitoring your blood glucose levels for toaster purchase decision making.
Oh mate, I reckon there's somebody out there who thinks that might get into YC.
Okay, let's do a couple of minutes on no longer throwing stones and just thinking about how we could use ML to improve prediction in marketing in this space. So I've got a couple of ideas because I prepared this section, so I'll start.
Yeah, well, I mean, yeah, you start, and that gives me time to think.
So I think what I've been learning about this is that like rather than like understanding the like using all the data to find out how the decision was made, you're better off trying to like find stable predictors, like one or two things that would help lead up to the purchase of that decision, and finding people that are similar to that. And I think I'm not like this might not be that new, but what I'm saying there is like, when people figured out that when someone buys prenatal vitamins, it probably means that they're pregnant. They're probably going to purchase a stroller in a few months' time. Find those links, and I think ML could be useful for finding those links within the like copious amounts of data that we now have on individuals. And I'm sure there's stable predictors within very, very niche groups that we could start to predict that have been overlooked. Like, for example, the iPhone is obviously a stable predictor, but it's a huge freaking group. How could you like layer on with machine learning to find niche and more and more niche audiences within that with certain other predictors? So, for example, they own an iPhone, plus they have a Google Drive account. What does that say about the individual, and how would that like create a niche group around that would help you predict certain decisions? So I think that's one area, and that's more of a like data processing, I think, almost, and like filtering of individuals rather than a machine learning exercise. But I think that's kind of like one space.
Yeah, definitely. I mean, another one, given the current hotness of generative models, I think, experimenting with AI copy, your Google search ads, you might put the first two in, and then it generates 500 additional ads, which are then assessed in a very traditional statistical way, which is which one performed the best in terms of ROI. Yeah. But I think our text generation models are probably at the stage where it could do that. Yeah. Image generation's probably getting there, depending on what you're selling. So I think that's another area where AI can, I guess, be used as a point of leverage, which is, nobody wants to generate 500 different search ads. That seems like torture. So let's generate some concepts and, make the AI generate 500 different ads. But in terms of their, performance, we just track that in the normal basic way with basic statistics that do a very good job of knowing which one's the best.
Yeah, exactly. And I think like so you stole my second one, so good job. But I think the point of that one as well is that you're like switching it from like trying to get AI to craft the perfect message to say please model, make me 500, and we will then release these into the wild, and then you'll get your little token machine dopamine hit on the other side of it when we figure out which one had the best ROI, and then we'll go from there.
Yeah, definitely. And I mean, learning the hot chook of your particular company is probably another case where AI can help. It's like, look, let's not assume that we can pick for an individual customer what's going to work the best, but maybe let's think about what out of our catalog is going to present the best to people on average. You probably don't need AI to do that, let's be honest, but you could use a simple machine learning model to start helping with that.
Yeah, good.
Yeah.
So, in summary, remember the hot chook.
Hot chooks, yes.
Alrighty, let's switch to grapes. I took a photo of grapes last week after we talked about this.
Did you?
To send to you, and wanted to send a joke to you about predicting seeing whether you could figure out the yield of this field, but then didn't think it was funny enough, so I didn't send it to you. So I thought I'd tell it to you here.
Yeah, good. Well, it's definitely funny now. So this is a paper I read. Matches this theme of like, should I have used AI? ? And then what is it? Gödel's law or whatever, which is when people pose an article on the internet with the question mark at the end, the answer is always no.
Never heard of that.
Yeah, I don't know if it's Gödel's law. It's somebody's law. Anyway, whatever. If you ever see an article with a question mark, assume the answer is no, and then read it, and see if I'm wrong. That's my stable predictor. But anyway, this was a group out of, I believe it was in California, but I could be wrong about that. But they were an agricultural research group, sort of a tech in agriculture group, and a couple of people from one of these vineyards, and they wanted to do yield estimation. So what that is as your grapes are growing on your vines, you want to have an idea of how many grapes there are going to be at the end of the season so that you can start to price your grapes and start to estimate your future revenues and do a little bit of financial forecasting. Are you going to make the cut this year?
Is accurate yield like not having an accurate yield a huge problem for the grape industry, or is it?
So this was a question I really couldn't find an answer to. Like you can make a lot of arguments about like, yeah, well, if I'm making wine, I need to know how many bottles and casks and things I need to put my wine in. And like, yeah, sure. But then nobody in this paper or in any of the sort of material it cited that I read really said how accurate yield estimation needed to be. Which I think, similar to this marketing work, comes down to the like, somebody's going to sell you an ML product that claims 4 digits of accuracy. But really, if you get it plus or minus 20%, you'll be fine. And the plus or minus 20% version costs $4 a month, whereas the 4-digit one costs 20 grand a month kind of thing.
Yeah. Because like my initial thought is like, why do this in grapes? Why wouldn't you do this in like a crop where like if we're off by 2%, thousands of people, hundreds of thousands of people starve, like wheat or rice or something like that. But
yeah, and it's a funny thing in that like I think for a lot of these crops, right, like you're really growing crops at such razor thin margins that you're not going to know the difference between like famine and not. Like sure, if there's a blight that blasts through your wheat fields, that's going to be terrible for the local populace. But you're not going to need an AI model to know that like you've had to remove 3/4 of your wheat crop. Yeah. But anyway, let's get back to this paper. So, they were trying to design a computer vision system to help with this. They didn't want to do aerial photography, either satellite or drones, because that was too complicated and inaccurate. So they designed this little sort of ground-based rover robot that would drive in between all of the different trellises and take photos on either side. And the idea was then to take that collection of photos and use that to estimate the overall yield and also some sort of per trellis yield of this.
Sounds way simpler.
Yeah, Yeah, I know, right? And for reference here, the hot chook in this scenario, or the sensible default was somebody would walk around to a sampled number of trellises, let's say 1% of trellises, uh, cut off one bunch of grapes, weigh that one bunch of grapes, count the number of grapes on that trellis, times that weight by the number of grapes on that trellis by the number of trellises in the yard, do some basic averaging and say, yeah, it's probably this. And that is accurate to about 10%, according to some of these papers. But it was deemed far too complex and inaccurate for mass use. So they built their robot. And they built this robot and they collected a whole bunch of data. So this is something that they did a nice job of. They took a ton of photos. They took photos prior to the harvest, and then they did, I don't know if it was a partial or full harvest, but they weighted at a whole bunch of points along the different trellises. The terrain was quite variable. So they had good variability in their data. Don't get me wrong. And then they trained a couple of different ML methods. They trained an object detection method, which would detect individual grapes, count the number of pixels in those grapes, and correlate that with yield. And then they did another one or two different models, a transformer-based model and I think a simpler convolutional neural network that was doing a regression model, which would take photos and predict yield directly. So you'd put a photo in and the output would be a number that you could then calibrate against an actual yield number. And so they did all this. It turned out to be about 20% error margin in all those cases. The object detection was much worse. That one I think is worse because they trained a second AI model to then label the data to then train their overall AI model, which just seems like stacking errors on errors to me. And yeah, their regression model was, it was okay. But not really. Like it wasn't particularly useful. It didn't have a lot of explainability or correlation in the regression. And it was a very complicated setup. And to me, it struck me as, it's interesting enough research. Don't get me wrong. People can do whatever research they want. I don't mind. But I think it's another case of maybe we didn't need AI for this. Or maybe there was areas where we could have put AI that would have had higher ROI than building a robot that drives between the trellises and takes photos and estimates the
partial automation rather than complete automation.
Yeah, exactly. So, in this case, what was the actual bottleneck of manual sampling, and how do you speed that up? If you replaced 1% of your trellises with, slightly more advanced trellises that had some sort of weight sensor in them and could measure how much vine had grown on that trellis, could you get most of the work done? Or something like that.
So I think, like considering these problems, right? There's like, used to use this old framework in the old old consulting days where it was like you started off with thinking about like, all right, could you completely eliminate all of the human touches in a place when you're automating it? And you would consider that, and you would like map all the human touch points and consider the cost or the danger, depending on what you were like trying to consider, what you were trying to save on there, whether it was time or whether it was like safety or something like that. And there'd be some areas which like the cost of like removing the human step would just be way too high. And so, all right, you'd eliminate the human steps that you could, the easy ones. So, for example, like in this grape growing one, like maybe counting the grapes, that's an easy one to eliminate. Something AI is perfect for. Very time consuming from a human point of view, easy for it. Then you'd look at the ones that you couldn't get rid of. You'd be like, all right, there's humans involved in this still. What could we reduce the humans in? So, for example, instead of someone walking up and down every single trellis counting the number of grapes in it or something, maybe you could use an aerial shot to measure the length of it or something like that. And then the final thing that you would do is for those things that you couldn't reduce the human impact on, you look at how could you improve the human's interaction in it. So like instead of it taking 100% of the time, could you take it to 80% of the time it takes and things like that. I really feel like this study, well, if this was before it goes into commercial, they need to consider this from that point of view, because it sounds like the complication to me sounds like they tried to basically replicate the same way that humans do it, but completely automated.
Mm. Yeah, definitely. I totally agree. And I think, we are tech people. It's not like, I think if you were a massive skeptic 15 years ago, you could say, look at these solar panels. They're so complicated. They're shitty yield, all of this sort of stuff. Why would we do this? It's so pointless. But I think there was a clear value unlock, which is like you can get energy from the sun. That's different. That's new. Whereas I feel like a lot of these AI applications are not really, they don't really have that same unlock. It's not just that like, but 10 generations from now, this robot's going to be perfect. It's that even if this robot was perfect, it would need to be pretty damn cheap to really make a difference. And even if it was correct and could give you the yield down to the gram, is that actually going to make a difference to the wine
What decision
industry?
does it affect?
And is this the most significant decision that we can affect within the wine industry? And should we be focusing there instead? Because I dare say that there's probably a lot of bottlenecks in this supply chain, as there are in any.
So what let's step away from the grape growing industry and think about like where could this be applied, or like where do you think this could lead in a more I'll say impactful exploration?
Look, I think monitoring agricultural changes is probably it's a big and important field. If you were in a dangerous environment, a hard to access environment, or anything like that, or you wanted to have a low impact, let's say you were looking at species monitoring in a rainforest somewhere where there was poor access, and if you wanted to get in, you'd have to cut down a bunch of trees and hack and slash your way through. Yeah, sure, maybe a robotic solution that could be slow and low impact would be a great solution. And you could count the bonobos or whatever else it was that you wanted to count in a very useful way. But most agricultural setups are pretty optimized for humans, just given their nature. So I think it's an odd application in my books to use this for yield prediction there. Maybe if you were growing, I don't know, saffron or something, where it's like a little bit of error can be extremely costly, you might do that. But again, I don't know. It feels like optimization for the sake of optimization, or AI for the sake of AI, rather than here is a problem that is going to either be uniquely solved by AI, so it was unsolvable before, or we can get an order of magnitude difference in either cost or accuracy from AI. None of which I think this problem had.
Yeah, it does. It does seem a little bit academic, I would say.
Yeah, definitely. And in that regard, I fully support it. If people can get funding for their academic curiosities, go for it. I'm not here to judge what should and shouldn't be done academically. I think it's great. Who knows? Maybe this gave somebody an idea for a bonobo camera, and we'll, see a massive rise in endangered species. Whatever. But I think grapes will be counted by human estimates for some time to come.
Did they have any great names with like grape or wine acronyms in it? Like was the like robot called like Vino or something?
No, they didn't. No, they should have. Even their robot didn't. As far as I remember, didn't have a particular name, which is a shame. I feel like it's a good opportunity for good puns or good acronyms. During my PhD, anytime you came up with some new algorithm or whatever else, you tried to think of a funny or interesting name for what you did. So why they didn't do that here? Maybe that was the red flag that I should have seen from the
Can't
start.
wait for the Chook algorithm for predictive item purchases.
The hot
Consumer heuristic optimization.
.ai.
No, can't do it. Someone come up with it for us.
Don't know, but it'll be something.
Yeah.
You wait and see.
The
You
Chook.
wait and see. Very good, very good. Well, man, I feel like we're coming up to an hour and we've had stable video connection so far. So let's not tempt fate and wrap this one up for the week. We can finally get episode 16 out. But before we part ways, anything you want to plug? Any cool
Welcome
stuff
to
you've
all our
seen
new
this week?
subscribers. We're up to 34, 35. Hello.
Yes. Hello.
Welcome. We're hopefully going to be having a few more videos in different parts of the channel coming out soon as well. I've actually signed up for an IBM course on AI. So like my background is I have no training and have never written a line of code when it comes to AI. I've just been running a company that does it for the last 4 years with Elliot, and so I've decided to. I got a bit of time at the moment, so it was like, oh, why don't I just go to the next level on this? So I'm doing a 5-week course, and I'm going to be summarizing it and recording stuff on it. Probably not useful to anyone who knows what they're doing, but for anyone who's looking to get into the space, it'll be on the channel for you.
Very, very cool. Well, I mean, my thing to plug is just this podcast, this channel. Please subscribe if you haven't already. Thank you for checking out our videos, all of that good stuff. And I suppose if there is anything you'd love for us to talk about, the best place at the moment is just to hit us up in the comments. We might think of a better way to do that in the future, but for now, let us know. Let us know what you see, what's cool, what's happening, and we'll be back next week for episode 19, I think, unless something tragic happens to this recording.
We're not doing this a fourth time. This is going up.
Yeah, no, this is going up no matter what. Something will go up. It might be an hour of silence, but something will go up. Yes, poor Lizzie. All right, well, ta-ta for now, folks. See you next time. Bye.